So hello everyone. In this video we will be covering the topic data preparation. In that we have the following few tasks. The first one is how to add an index field using Python. So for this we have to import the pandas package and then import the dataset named bank underscore tree by using the read underscore csv function of pandas and by specifying the file's location. This is how we import the dataset and we have stored it in a variable. To create the index, we first need to find the number of records and columns in the dataset. For that, we have a function named shape. Using shape after the name of dataset will give us the number of rows and columns in the dataset. The first number is the output of records. The second is the number of variables. So let's implement this. Yeah. So here execute this code. These are the number of records and these are the number of fields, that is columns. Further, we know the number of records. We need to create a new variable that assigns every record a unique integer. So we will write this using the series and range function. Both are nested. That is, the nested command series and range create a string of numbers whose lower bound is 0 and upper bound is the number of records. Since the series command is contained in the pandas package and we renamed the pandas package pd, we preface the series command with pd as and a period. The result is the code pd.series. Note that the lower bound of range command is 0 and not 1 as Python begins counting locations at 0. We save the series of numbers as a new variable in the dataset index by assigning the output of pd.series range to the index variable of bank underscore tree dataset using this. Now to view the dataset with its new variable, we can look at the head of the dataset. So this is what we have done here. Hmm. These are the indexes. Yes. Using head after the name of dataset will generate output containing the first and last 30 records of every variable in the dataset. Let's execute. This is the output for the following code. The next task is how to find, change misleading field values using Python. For this, we will be using the NumPy package. We need to identify all records with day underscore one since underscore previous value of 9999 and replace them with the Python code for missing numbers nan. Once the replacement is made, we will save the variable under the days since previous variable name, effectively overriding the previous variable's values. This is how we will be doing the following task using the replace function. The command replace finds each instance of this in the following variable and replaces it with the value n. To save the newly edited variable under its original name, we set the right hand side value to the original, that is days since underscore previous variable on the left by reusing the variable name bank underscore train. So have a look at code. This is the code. We have read the CSV file. We have replaced 991 with the NaN in the each column, and this is what we're plotting the histogram. Let's execute the command, and we have our histogram here. This is the histogram of age. This is the histogram without output. We have drawn the histogram using the dot plot function after the variable name. The next one is how to re-express categorical field values using Python. We will replicate the education variable and its education underscore numeric in preparation for replacing its categorical values with numeric ones. So we have done this here. This is re-expressing values of education as numeric. This is our bar graph. The right hand side of equals specifies the education variable. Let's have a look at the code. And the equal sign assigns those values to the left hand side. There is currently no variable named education underscore rubric. So one will be created and given the values of the variable education. We need to set up a dictionary specifically for converting the categorical values in the education underscore numeric variable to numeric values. We declare a dictionary using this curly braces. We have created the dictionary here. Inside the dictionary, we use education underscore numeric to specify the variable which we want to recode, followed by colon and another set of brackets. That is what we have written here in the code. Next, within this second set of curly brackets, we specify the decoding in the following order. Variable's original value, each specification is separated by comma. For missing value, NaN where necessary. Finally, we replace it using the replace function. And it will replace according to the dictionary. So just a second. So this is the output for the following code. The next task is how to standardize numeric fields using Python. So for this we will be using SciPy and statistics package. From the SciPy package we will standardize the age variable and save it as new variable age underscore z. This is what we have written here using the z-score function. The z-score function calculates the z value of the given variable, in this case age, written in the code as this. As the z-score command is a part of stats package, we write the command as stats.zscore. We save it in a new variable in the dataset age underscore z. So code for this is, let's execute this command. So here we have standardized the employed field. Next task is how to identify outliers using Python. Outliers are the unnecessary values present in our data set. So we will continue using the age underscore z variable that we created in the previous section. We will find outliers by using the query function, which identifies rows that meets a particular condition. The condition is we want all the return records to meet is given as age underscore z greater than 3 or less than equal to minus 3. All records which meet the specified conditions are triggered. So let's have a look at the code. This is the z score calculated for age underscore z. And we have identified the outliers using the query function and sorted the values is in descending order. Let's look at the output of the code. Yes, these are the outliers for the following dataset. So that's all for this video.